Welcome to the Ultralight Airplane Workshop. My name is Leon. Let's talk a little bit about composite carbon fiber sandwich construction utilizing vacuum resin infusion. If you've seen my video on the success I finally had on getting a good mold side surface on my carbon fiber samples, you'll know that my goal was to at least duplicate or exceed the qualities of aluminum, 6061 T6 aluminum sheet. And what I've been comparing my samples against is this 12-inch by 12-inch sheet of 16 thousandths thick aluminum. So if I can beat or exceed the weight, in other words, less weight than this piece of aluminum, which is 101 grams, and I can meet or beat the shear strength, then I should be able to make an ultralight airplane out of carbon fiber, because there has been a successful ultralight made of sheet aluminum, and that's the Maury Hummel Ultracruiser. So I spent many months working on getting a good vacuum resin infusion on carbon fiber samples to compare against the aluminum sheet. And the very first carbon fiber example that I got that was a success weighed 62 grams, 12 inches by 12 inches. And so I was pretty excited about that. Now I haven't done shear strength testing on it yet, and that's in a future video, we'll get to that. But at least weight-wise, and just feeling it bend, it seems to be fairly comparable to the aluminum, if not possibly better. Now this was a 2x2 twill, 2 layers, 200 gram. And it's 20 thousandths thick, so the thickness really doesn't matter if it's more or less than the aluminum. I'm more interested in the weight and the strength properties. One of the things I don't like about aluminum, especially the way some airplanes have used it, for example, the CA2 has flat fuselage sides, and so you get something called oil canning, where even though it may be flat sitting on the bench or even sitting on the ground, when you go to fly it, once you start putting flight loads on it, it does some oil canning. It moves around and bends. One of the drawbacks to that is you lose some of your aerodynamics. Your air along the surface is going to be far more turbulent and you're going to have more drag. Plus the coefficient of lift, if it's a wing, is going to drop, or a horizontal tail or vertical tail. So that's kind of a drawback. And one of the reasons for going with composites on this new UWS-1 ultralight design is I want to get as smooth a surface as I can to try to reduce drag, since I want to use electric power. And electric power doesn't have a whole lot of duration, so I'm trying to extend the duration by having good aerodynamics. So I'd like to get rid of this oil canning feature. Well, one way to do that is make it stiffer. And to make it stiffer, you can add a core. Here's the first sandwich test that I did. So this is also 12-inch by 12-inch. It has the spread toe on both sides, and although you can't tell, this was actually the mold side. This is the flow media side. I had a problem with this one. This was just plain Divinycell H45, so that's about 3 pounds per cubic foot density, 1/8 inch thick, 1 ply of the spread toe on this side, 1 ply of the spread toe on this side. And then I just tried to do a vacuum infusion on it. Well, it didn't even come close to working. This was the mold side. Ignore this here that doesn't have a good finish on it. You can see from this smoother side how far the epoxy made it. It kind of made it up a little bit into here, a little bit into here. So that's as far as it made it during the infusion. All the rest of this was just dry fabric. So that was a complete failure. What I did, though, is to try to salvage this and maybe be able to do some tests on it and see if I'm even close to the ballpark as far as weight would go. So after this had cured, I went and did a wet layup and just put some peel ply on it and just let it cure. So at least I could get an idea if the weight is going to be in the ballpark. And it turns out this was 90 grams. Now the aluminum was 100 grams, 101. So by golly, we're in the ballpark. If you painted this, you'd get probably about 10 grams of paint over a 1 foot square area, and that would put me right up even with the aluminum. But this thing is stiff. Just by hand, I can barely get it to bend. Not much at all. So that was really encouraging. So I tried to do another test where I would give the epoxy as many paths through the foam as I could think of. I think I went a little bit overboard. So my plan was to take the 1/8 inch thick H45 Divinycell and poke lots of holes in it. And I'm sure you've seen some of the foam core that has holes in it. And I made myself a quick and dirty little device with nails in it, which had 1 inch spacing on the nails, except if you came in 1/2 inch, it had another line of nails, but it was offset by 1/2 inch. And then I pushed this through the foam to make my series of holes. Once I had my series of holes, then I took a knife and a straight edge and I scored most of the way through the foam, hooking up all the holes. So then I went and did vacuum infusion on that. Unfortunately, I had some problems with my vacuum bag during that infusion. This is the mold surface. This is the input side. I got a fantastic mold surface clear over until about 1 inch from the end, maybe 1.5 inches from the end, and then it stopped. And the rest of it was dry. So I came awfully close to getting a good mold surface on this part. Now, like I said, I had some vacuum bag issues, and I think what was happening here at the end is the vacuum was running too fast on the flow media side. Ended up trapping air at the exit end, and then a little bit later I actually had a vacuum bag leak. I lost my vacuum pressure, and I think the epoxy from the vacuum line ran back into the part because the weight on the part turned out to be 141 grams. That's compared to 90 grams from my previous test. Now, you would expect it to be a little bit heavier just because of all the holes and all the score lines I put in it, but I wouldn't expect it to be that much heavier. That's almost 50% heavier. But I was encouraged that I could potentially get a good mold side finish. And a little bit later, I'll tell you why this gave me another idea that I want to try out. This was my next test. I wanted to see how different hole patterns would affect the flow on the mold surface side, but this time without any scoring. So this was the test. This is the direction the epoxy was flowing. Now this is a slightly different fabric here. This is a plus 45, minus 45 bias fabric. It's not woven like the twills. It's just one layer going this direction and then another layer going the opposite direction. And then they use a little bit of thread to try to sew them together. But you can kind of see what the hole patterns was. This was a hole every 1/2 inch in 1/2 inch squares. This was this hole pattern. And then this was a hole every inch square. One of the things that I changed for this test also is I changed the way I make the holes. One of the issues with this method by using nails is that although some foam would get pushed out of the hole, a lot of foam would actually get pushed into the sides of the hole. And when you pulled the nail back out, it would expand and partially fill the hole back up again. So that was kind of annoying. I was getting pretty small holes. So I changed the way I was doing holes, and I just decided to do it entirely manually. I took a larger nail and I ground the tip off. So it's a lot like a punch. And I used that to punch the holes through. And that made a very nice hole the size of the nail. And it also made these holes a little bit bigger, so I got a little bit better flow through. So as you can see, having far more holes made it go a little bit farther, and that's what you would expect. I had hoped that this one would go all the way, and then maybe this would go up close, and then this would be farther away, but I was not able to go all the way with this. Now, one of the problems with using this fabric and this spread toe fabric is that both of these are difficult to use in vacuum infusion. The threads within the toes are tightly packed together. This one only has a few crimps to help epoxy go through. This basically has no crimps. So the epoxy doesn't have any gaps to flow through. It actually has to go through the fabric itself. There aren't any crimps to go through. And you can see it was only soaking through right where the holes are. I really would like to use this fabric. It's fairly inexpensive, and it should be very strong and fairly light. The drawback to this fabric is it doesn't follow compound curves very well. So it should be pretty good for the skin side of a surface that doesn't have a lot of compound curve to it. For example, the root of the wing where it only has a simple curve. This fabric should work pretty well there. This fabric follows curves much better. You can see where on these corners, it did a pretty good job of following these corners. So this would be a pretty good fabric on the inside and more complex curves. The problem is that this is a far more expensive fabric. This was my next test. Again, I used different hole patterns, and I decided this time I would use a fabric on the flow media side that was much easier for epoxy to flow through. But I still used the same hole patterns I used before. Now let's look at the side. So this was encouraging. I was able to get the epoxy to flow the entire length. So that was very encouraging. And it did a fairly good job of filling in the weave of the fabric, but not perfect. There are a few places on this where it did a good job, but in the crimps, it did not quite fill it in. And another issue is that you can actually see the whole pattern. You may not be able to see it, but I can kind of see where all the holes are. So that was a little bit discouraging. But the weight-wise, let me put that here. Weight-wise, it turned out pretty good. They were all very close, which kind of surprised me. I thought this one would be far heavier. What I did is I weighed them and then converted them to what it would be for a 12-inch by 12-inch piece so I could compare with my previous samples. So we have 92 grams, 92 grams, and 94 grams. So these two are almost identical in weight. This one was just fractionally heavier, but I don't think that really counts. There could have been some measurement errors on my part. And this was only, what, about 2 grams heavier. So they're all nearly identical in weight, which kind of surprised me. So my thinking is that having a fabric on this flow media side that's easier for epoxy to flow through gave me a better finish. That's my working hypothesis. And again, these were all H45, and that's important because I started playing with some H80 core in some of my later tests. So I decided, well, let's do some scoring and see how that affects it. I won't get quite as carried away as before, but we would do a test and see how that worked. So this is the next test. Now I'm still using the biaxial, but I decided to use a fabric on the flow media side that epoxy could flow through much easier, and that was in the hopes that I would get a better finish. And I did get a slightly better finish. You won't be able to really tell on the camera, but here in these grooves where the two sides of the fabric were sewn together, I did get a slightly fuller groove, but it didn't completely fill. This one's a little more open. So at least that part is better. Now I used the same hole patterns, and this time I decided to add some scoring. So this was scored, let me flip this over. Yeah. So this was 1 inch by 1 inch spacing on the holes, and I scored the holes together. So I have 1 inch by 1 inch spacing on the scoring. And so I did both horizontal and vertical, 0 and 9 degrees. This one is also 1 inch by 1 inch spacing, but without the scoring. And this is 1 inch by 1 inch spacing with scoring, the same as this. But the difference between these two is I used an H80 core in this one. These are both H45 core. So the H80 is about a 5 pound per cubic foot density foam. And like I said before, the H45s are around 3 pounds per cubic feet. Now I got pretty much identical results on all three of these as far as surface finish goes. I really can't see much difference. I can see the score lines through the finish, which is kind of unfortunate. It kind of got print through there. and I can see where my holes are too. So I got a semi-good finish, but not as good as I want. Let's talk about the weights. So I converted these from their actual weights, around 62 grams, to equivalent 1 foot by 1 foot weights. So I got 102 grams, 117 grams, and again 117 grams. That's quite a bit of difference. I'm a little surprised at that. I thought the H80 would end up weighing about the same as the H45. That's because the H80, being a higher density, the holes on the surface that epoxy is going to soak into will be smaller. So the weight of epoxy that is soaked up by the foam should be less, even though the foam weighs more. Now I did a weight on the foam at this size, not the 12-inch size, and the H80 weighed 3 grams more than the H45. So you could just kind of assume it's roughly doubled. So on a 12 by 12 would be 5 or 6 grams heavier. But it looks like the epoxy soak up makes a huge difference. But like I said, I was not very happy with my mold side, so more experiments. At Oshkosh 2019, I got a composites tip just briefly that intrigued me, but I didn't get a chance to ask more about it. And that is that if you rough up your mold surface, you can break up the surface tension of your epoxy as you're infusing. That will help it fill the mold surface of your carbon fiber better. I thought, well, I'd like to try that. I really have no idea how I should go about it, but let's just try something blindly, see what happens. So what I did is I took my mold surface and I sanded it with 120 grit sandpaper, and I sanded it in 2 directions, 0 degrees, then I sanded it 90 degrees. For the mold release, I decided not to use my semi-permanent mold release I had been using. It goes on a little bit thick and it builds up a layer, and I was concerned that that would actually fill in all these small grooves I had put in my mold surface using the 120 grit sandpaper. And so what I did is I switched back to my Free Coat 700 NC. That dries to a very thin coating. And I thought, well, maybe it won't fill in the grooves that I've sanded into my mold surface. Well, I'm pretty sure it did not fill it in. As I'm going to show here, it was harder than blazes to get my samples off this mold surface. There are several possibilities for why that might be. One is my 700 NC mold release is over a year old. It's supposed to have a shelf life of about 7 months, and we're at about 13, 14 months now that I've had it. So it could be that it's just gone bad and didn't release very well. Another possibility is that the sides of the grooves may have been gripping pretty hard and may make it hard to release. As you may know, when you have a mold that is nearly vertical and you're trying to pull your part out along that vertical edge instead of away, like peeling it, you're sliding it along that edge, it is hard to get a release. Well, those edges of the grooves may be having the same action where we're trying to slide along those edges of the grooves when we're trying to pull the part out. So that could be it. Another possibility is that the mold release did not get fully down into the grooves, but when we pulled the epoxy in through the vacuum, the epoxy did get down in there, and so what we're having to do is have micro fractures breaking loose. So some of it has mold release, some doesn't. And that would be a lot like the action of the peel ply. When you're pulling off peel ply, you're creating micro fractures in the epoxy. It could be that we had that same action here. But regardless, I did get the pieces off finally. And as you can see, I'll do a comparison here. So this is with the smooth surface. This is with the 120 grit surface. And so you get more of a matte finish. But everything else was nearly the same. I did not do any scoring. I did the 1 inch by 1 inch holes through the foam, and the foam was the H80 density. But I got almost identical amount of fill of epoxy in my fabric at the mold surface, even though they have a different amount of shininess to them. So I'll kind of tilt them up and down so maybe you can kind of see that. I did make a couple other changes too. With this test, I did a mixture of fabrics on the mold surface side. I used my 2x2 spread toe twill and my biaxial. And I got almost identical amount of fill. Down in the crimps, it just barely didn't quite fill. But I think there is enough fill that this would still be a strong mold surface. I think it would be usable. This one I'm not so sure about. And then of course on the flow media side, I used a fabric. This is 2x2 twills to help the epoxy flow through. Let's talk about weights here. Now I also did another flow through media. This is a 4 harness satin over on my left, your right. And I wanted to see if it would flow a little bit better, but I did not see any difference between the 2x2 twill and the 4 harness satin as far as flow through went. And then for weights, the one with the 2x2 spread toe surface had an equivalent 12-inch by 12-inch weight of 101 grams. And then both of these are around 94 and 93, so they're almost identical as far as weight goes. So at the moment, my thinking is to do something very similar to this, where I have an easy flow carbon fiber on the inside. On the skin side, I'm going to use a higher strength carbon fiber. So all of the shear stress, I'm thinking, can be carried by this fabric. And then this fabric will just provide stiffness to prevent oil canning. And it should allow me to use fewer ribs, which should save us some weight. Now I could do a little more testing with this scratched up mold surface, maybe switch to something like a 300 grit, but I don't think I will. I think I like the smooth mold surface of my parts a little bit better than this matte, although it's possible that paint would stick better to this matte finish. Now let me go back to one of my early failures and talk about it just a little bit more. Now this early failure was one where I had a problem with my vacuum bag developing a leak after I had gone ahead and left it to cure. And like I said, what I think happened is epoxy got pulled back into the part. And I've got a fantastic finish where I have a finish. That got me to thinking, what if I do a little test where I use my normal vacuum, which pulls 28.5 inches of mercury, do the whole infusion with that. Once I'm done with my infusion, I switch to my 25.5 inch vacuum. And so that will let the vacuum slowly reduce down. Well, if you think about when you're outgassing epoxy, it's still bubbling a little bit right before you let the pressure in. But when you let the pressure back into your vacuum jar, those bubbles that were big suddenly shrink down to almost nothing. What happens if we reduce the vacuum in the part by 3 inches of mercury? Well, we should get all of the little bits of air that are in this kind of fill, where there's just a little bit in there, that should shrink down. And that's going to pull epoxy back in and fill this in and maybe give me a good surface finish. But by still having the 25.5 inches of vacuum, it shouldn't pull much epoxy in. It should still have a fairly good fiber to epoxy ratio. Well, I'm going to do a test and find out. The next video that comes out should be another UWS-1 Ultralight airplane design video, and that one will cover the determination of thrust and motor power for the Ultralight airplane. The one following that will be the experiment I'm just now getting to run, which is doing the vacuum infusion with 2 different vacuum pressures. If you haven't done so, don't forget to click that little subscribe button that just showed up there in the corner. Now let's get to it.